If the sun were to vanish at this very moment, nothing on Earth would change. For the next 8 minutes, the sky would remain bright, shadows would still fall in their usual direction, birds would continue their flight, oceans would move as they always do, and every human being would go about their routine without the slightest awareness that the central star holding this entire system together no longer exists. This delay is not philosophical, it is physical. Light takes time to travel. The distance between the Earth and the Sun is about 150 million kilometers, and even at the fastest speed in the universe, light needs roughly 8 minutes and 20 seconds to reach us. What we see when we look at the Sun is already the past. In that sense, we are always slightly disconnected from reality, always observing a delayed version of what truly is. But then, at the exact moment when the last photons arrive, the entire structure of life experiences a sudden and irreversible shift. The sky would collapse into darkness, not gradually like sunset, but instantly. There would be no twilight, no fading of color. One moment, full daylight. The next, a darkness deeper than any night humanity has ever experienced. Because even at night, the sky is not truly dark. The moon reflects sunlight. The stars emit their own distant glow. But in this scenario, the primary source of illumination in the solar system would be gone. The moon itself would become invisible, reduced to a cold, unlit rock drifting in space. Yet the disappearance of light is only the surface of a deeper change. Gravity also travels at the speed of light. This means that the sun's gravitational influence does not vanish instantly either. For those same 8 minutes, Earth would continue orbiting as if nothing had changed, still bound to a star that no longer exists. But when that gravitational signal finally reaches Earth, the effect would be immediate and absolute. The curved path of our orbit would break, and Earth would begin moving in a straight line, drifting into space along the tangent of its previous motion. This is not a violent ejection. There is no explosion, no sudden jolt. The planet would simply stop curving around the sun and continue forward into the darkness, carrying oceans, atmosphere, and life with it. For the first 60 seconds after the sun's disappearance becomes visible, the physical conditions on Earth would not change dramatically in terms of temperature. The planet has thermal inertia. It stores heat in its oceans, land, and atmosphere. 1 minute without sunlight would not freeze the world instantly. The temperature would begin to drop, but only slightly, fractions of a degree. Most people would not even notice the cooling immediately, but the psychological impact would be overwhelming. A sudden global darkness during what should be daytime would trigger confusion first, then fear. Electrical lights would turn on automatically in many places, but they would feel inadequate, artificial, unable to replace the vast natural illumination that vanished in an instant. Communication systems would flood with questions. Observatories would scramble to understand. Within seconds, realization would spread that this is not an eclipse, not a storm, not a local phenomenon. It is universal. The sun is gone. Even within that first minute, something more subtle begins to happen. Photosynthesis, the fundamental process that sustains almost all life on Earth, stops instantly. Plants rely on sunlight to convert carbon dioxide and water into energy. Without light, this process halts. For 60 seconds, the impact is negligible, but the interruption has begun from this continuous input of solar energy, and even a brief disruption reveals how dependent life is on a constant flow of light. The atmosphere, too, begins to respond. The upper layers, which are heated directly by solar radiation, start to cool. Winds and pressure systems, driven by uneven heating of Earth's surface, begin to lose their driving force. Again, within 1 minute, these changes are microscopic, but they are real. The system is already destabilizing. What is more profound is how quickly order begins to unravel once the central source is removed. The sun is not just a distant object providing light. It is the anchor of an entire system, gravitationally, thermally, biologically. Its presence defines the rhythm of day and night, the cycle of seasons, the flow of energy through ecosystems, and even the stability of Earth's orbit. A single minute without it does not destroy life immediately, but it exposes how fragile the balance truly is. If the sun were to return after exactly 60 seconds, much of this damage would be reversible. Light would flood back into the system after another 8-minute delay. Gravity would reassert itself, pulling Earth back into orbit. The temperature drop would stabilize. Life would continue, but the event would leave a mark, not just physically, but intellectually. It would force a recognition that what appears stable is maintained by continuous, precise conditions. This raises a deeper question that goes beyond the hypothetical scenario. Why are those conditions so precisely maintained in the first place? The sun is not just any star. It is remarkably stable. Its energy output does not fluctuate wildly. Its size, temperature, and composition are such that it produces a steady stream of radiation over billions of years. Earth, in turn, is positioned at a distance where this energy is neither too intense nor too weak. Slightly closer, and oceans would evaporate, slightly farther, and water would freeze permanently. This region is often called the habitable zone, but the term can make it sound accidental, as if Earth simply happened to fall into the right place. In reality, the conditions required for life are not defined by a single factor, but by a combination of many variables working together: orbital stability, atmospheric composition, magnetic field, planetary mass, and the long-term behavior of the star itself. The balance is not just delicate, it is interconnected. The sun converts mass into energy through nuclear fusion, releasing an enormous amount of power every second. This energy travels across space, reaching Earth and sustaining life. The same energy drives weather systems, powers ocean currents, and fuels the chemical reactions that make life possible. Without a constant input of solar energy, Earth would become a frozen, lifeless world in a matter of time. But the sun's role is not limited to energy. Its gravity holds the solar system together. Planets orbit in stable paths because of the sun's mass. Remove it, and the entire system dissolves into independent trajectories. This dual role, providing both energy and structure, reveals something about the nature of order in the universe. Systems do not maintain themselves without underlying principles. They depend on constants, relationships, and interactions that must remain consistent over time. The Quran repeatedly draws attention to this consistency, not in technical terms, but in observable reality. It speaks of the sun and the moon moving with precision, each following a calculated path. The wording suggests not randomness, but measurement, not chaos, but order. It points to the balance in creation, where everything operates within limits that are neither exceeded nor neglected. Another verse describes the sun as a radiant lamp, and the moon as a reflected light, distinguishing between sources of light and those that merely reflect it. This distinction, simple in language, aligns with what we now understand about celestial bodies. The sun generates its own light through internal processes, while the moon shines by reflecting that light. These are not scientific explanations in the modern sense, but they direct attention toward the structure of reality. They encourage observation and reflection. Prophet Muhammad also spoke about natural phenomena not as random events, but as signs, indicators of something deeper. When eclipses occurred, he clarified that they are not tied to human events, but are part of a system established by Allah. This shifts the perspective from superstition to understanding, from fear to reflection. Returning to the scenario of the sun's disappearance, even for a minute, what becomes clear is not just the physical consequences, but the dependence embedded within existence. Life on Earth is not self-sustaining in isolation. It is part of a larger system, reliant on continuous input and stable conditions. And yet, despite this dependence, the system operates with remarkable reliability. The sun rises every day, not randomly, but with precision. The Earth continues its orbit without deviation. Seasons follow predictable patterns. This consistency is so familiar that it is often taken for granted. But familiarity does not reduce complexity. It only hides it. Because behind every sunrise is a chain of processes that must remain uninterrupted: nuclear reactions in the sun's core, gravitational balance across space, the propagation of light through the vacuum, and the rotation of Earth itself. If any part of this chain were to fail, even briefly, the effects would be noticeable. If prolonged, they would be catastrophic. So the question is not simply what would happen if the sun disappeared for 1 minute. The deeper question is why it does not. Why does the system remain stable? Why do the laws governing it remain consistent? Why does the balance hold? Science can describe the mechanisms. It can model the interactions, predict outcomes, and measure variables. But it does not answer why the system exists in this particular form, with these particular properties, sustained over such vast periods of time.